Oh, right, champions, we're finally back to that 6G6-B Bassman that I did a million years ago, back in April. Friggin' hell. Anyway, we're finally back to that. So I've removed the caps, ready to reapply them with some silicone underneath. I've straightened the leads out because I want to put more of a gradual curve on them rather than this right angle stuff, just to prevent any future, fracturing or anything at that point. But we're just going to give the board a bit of a clean. I want to inspect underneath because looking here, the when the previous person did the recap, they left the leads for the old cables, for the old caps, sorry, there, instead of removing them, which is pretty easy. You just heat it up and pull the lead out, champ. But yeah, I just want to check underneath that there's no blobs of solder or anything as well. Well, we're there just to be sure. Set our mind at ease and whatnot. Got a bit of a hook on that one. Alright, champions, my microphone battery just died, but anyway, we'll run with the built-in mic in the camera. Here we go. All the caps reinstalled, a little bit of silicone under them, and just to prevent side-to-side movement, I've just put a little bead between them as well, since they did meet up pretty nicely. Cleaned a bit of corrosion off the leads, probably been exposed to a bit of moisture at some point, resoldered everything, put new link wires on the ground side. I like to have them visible so you know what's going on at a glance. Call me crazy, they probably look better with them on the other side, but hey, we've got the cover on there anyway, don't we, champions? So I've got to re-educate myself. It's been so long ago since I started this job as to what exactly I'm doing, so I'm just going to have a look at my job sheet and re-familiarise myself with the work order. We'll flip it over and get to work on the guts. Alright, so we've got her up and doing a bit of testing. We've got the bias sitting at about 65%-ish. But the mains is up around 246 volts today. So when that settles down to about 240, we'll be sitting around 60% approximately at a rough guesstimation. So done the majority of the work. Reflowed stuff. Put new leads on there with some heat shrink. Just secured stuff, went over pretty much all the solder joints, redone the grounds there, put heater balance resistors down there on the lamp, just working on the bias supply at the moment. Got to clean up the rest of that and settle on the values. We've done the ground connection there. I've just used one of the existing screw holes there and mounted a toothed eyelet. So like a sort of like a internal star washer as an eyelet, then a flat washer on top of that, a split washer on top of that, and then a nylock nut. So that's my preferred way of any grounding points to the chassis, and removed them all from the transformer hardware and just nipped all of that up. The caps nuts are still okay there. I may put some grid stoppers on it if there's any stability issues. It just helps with potential oscillation, that kind of thing. There's no grid stoppers on this stock design, where I believe they moved to it on the next generation. There is a like a snubber cap, a ceramic down there, which we were replaced because the stock one was all cracked around where the legs enter. But yeah, every single solder joint in this thing I had to check over. I don't trust anything the previous tech's done, because every time I have in the past, there's just, you check 99 solder connections and the 100th one, even though it looks good, is the one that fails, and it makes you look like a dickhead, and it's very embarrassing, and it makes you lose face in front of the customer. So this is a case of that. Down here, these ridiculously huge caps here, you use a Panasonic one and it's literally like 1/10 of the size and mass. There's been no attempt to secure these, so they're just vibrating around, and because they are fairly massive, they resonate at like fundamental frequencies with a guitar. Now, in a normal head cabinet, less of an issue. It's still an issue because you're transporting the thing too, so these are vibrating around as you're driving around with the amp in the back of the van or whatever. But in a combo, which this is, with a 15-inch driver, these will be vibrating and then fracturing their solder joints. Now that has occurred down here, which visually it looked okay, but you can see the movement there, and we can just lift that straight out. So that visually looked okay, partially because the wire insulation was pushed right up against the solder joint. So I think we can reuse these. I think they're ridiculous. I don't think they have any place in any product anymore. They're a relic of the past when making small capacitors was technically difficult. These days it's easy. These things are made using yesteryear technology with no advantage at all. But for some reason, people love looking at them. I don't know if it's like monkey brain finding a bright coloured, you know, berry in a tree or something. It's like harkens back to our prehistoric brain or something like that. But I just don't think they have any purpose in any amp, and neither do these massive things here. Because the problem is you've got your bypass resistors down there shoved up against the cap body, which you need access to. So siliconing it down is difficult, but because it's so large and heavy, it's got potential to crack its solder joints too. And yeah, granted, it does have 3 leads because you got the 2 coming out the top, but it's just unnecessarily large when we could use 2 tiny little V-shays that are about the size of a pinto bean or smaller. Like, look at it, it's just crazy. 2 of them and you got the same thing, and no problem securing the components because they're so light and small and compact, and you can still access the neighboring biasing resistors. Did I say bypass resistors before? I don't know. As soon as I turn the camera on, my brain just turns to mush, like more than usual. Alrighty, so I've cleaned up the soldering and we've put a little bead of silicon in there. Kind of reminiscent of a messer now, isn't it? Big orange drops with silicon everywhere. Meet your halfway solution. No silicon to the board, but I've siliconed the 2 caps to each other, which should damp their resonance quite a bit. And now it's like a 4-leg component rather than, you know, 2. So I haven't done it to the bypass cap down there because there are a bunch of components down there that you'll need access to in the future, to save you pulling out, you know, desoldering all 1, 2, 3, 4, 5, 6, 7 leads. You could just remove the bypass cap itself or the film caps. Anyway, I'm rambling. We did the same up on the phase inverter output caps as well. So I've had it under test for a while now. The bias is nice and stable. We've set it on some kind of strange values down there. I got 16k as the dropper and 1.5k as the input resistor. It was putting out a surprisingly large bias voltage to the supply there, so I've just had to tone that down a bit. It originally had 5881s in it as per the circuit, but it came in to me with 6L6s in there, so we've biased them to about 60%. So if it was to go back to 5881s, we'd have to tone that back a bit because they've only got a I forget what is it, 23 watts as opposed to 30 watts maximum plate dissipation. We've done all the mains wiring there. It's a bit difficult to keep the primaries completely isolated from the secondaries in this one because they don't come out the respective holes. You'd expect there'd be primaries coming out of one and secondaries out of the other, but it's not the case. So we've had to extend that heater wire a little bit down there as it was before, but the wiring was all melted, so we've redone that with some PVC. Got 2 fusible, a bit hard to see down there, but 2 fusible 100 ohm half watt metal film resistors there for the heater balance. And of course we've disconnected the heater center tap, which was previously grounded at the same point down there as the HT center tap. So again, I say it every time, but we come in with active to the fuse tip, and then the fuse ring to the power switch, and then power switch to the transformer, and neutral always attached to the transformer there. That's the blue wire. Redid the speaker connections down there because they were all tack soldered. Pretty much every component that was replaced, you can see the film cap there, 2 film caps there. I did that ceramic there, but I'll go into that shortly. But every component that had been replaced, the screen grid resistors, the old leads were still in the eyelet. Now, it can be tough to get all the leads in the eyelet how it is, let alone if there's old leads from a unused component in there too. But then the new component was just tack soldered to the blob of solder that still included the old lead in it. That's just laziness to me. You really need to pull out. If you're gonna, you need to pull out. If you're gonna, god damn it! Every video I have some double entendre. If you're gonna replace a component, remove the leads, please, and clean up the solder joints. Resolder it instead of just tack soldering it to the top. But, you know, if you're watching this channel, you already know that, don't you? Because you're a bloody champion. This was the, I don't know what you call it, shunt cap, I guess, between the 2 phase inverter outputs. You can see there the lead's been sort of tugged and it's cracked away at the ceramic there. So that allows, like, moisture ingress. And she's just not looking the best, so I'll change that with a nice V-Shay ceramite down there, my go-to caps if I can get my hands on them. And the phase inverter input coupling cap I believe it was it? Yeah. Someone had cut the lead off at some point, probably trying to track down board leakage, thinking it was a cap, and then just sort of tack soldered the cut off lead to the existing eyelet, so it was only holding on by like a millimeter or so, and I couldn't reuse that one because the leads are too short. So again, we replaced that with another nice little V-shade down there. And nothing special about these. They're just the cheapest possible ceramic going around, so in the bin they go. The only other thing to do was just replace that undersized grommet they had on there with the blanking grommet for the ground switch. Don't mind the weird music in the background if you can hear it. I'm listening to Pelican. Do love Pelican. Couldn't eat a whole one though. So I'll give the pots a quick clean up. They are remarkably clean actually, but I'll clean them, just give them a quick cleaning cycle, and same goes to the jacks. Just give them a flush with some ISO and check that all the shorting jacks have enough tension on them. There's a little trick to retension them, which I've shown in other videos. And then we'll just set it to bake over on the burn-in bench and just make sure everything's stable. Come back and play it periodically, and then she's ready to put back in the box and get out the door back to its loving customer. So sorry it took so long for the second edition on this one, champions. I've been juggling jobs like a crazy man here at the moment, trying to get parts on order and keep everyone happy, which I'm not sure I'm succeeding at, but anyway, just do the best we can. So until the next one, take it squeezy. I'll see you then.